Grasslands. Covering around 1/3 of the world's land surface, it is one of Earth's most biodiverse ecosystems, hosting a huge range of large grazing herbivores, carnivorous predators, insect and bird populations, and much more. From the beloved predator-prey relationships that we so often see in BBC documentaries, to some of nature's greatest spectacles. However, there is a process turning our once super biodiverse ecosystems into sprawling deserts, affecting not only the wildlife in these areas, but also civilization itself across the world. This process is better known as desertification, described as one of the greatest environmental challenges of our time. And now research shows that at least 100 million hectares of healthy land is lost each year, or in other words, 0.77% of Earth's total landmass degraded. We are losing far more land than we're able to restore, and estimates suggest that by 2030, the world would need to restore a whopping 1.5 billion hectares of degraded land. By using the Normalized Difference Vegetation Index, or NDVI, one can measure the loss of greenery across the globe. By using this satellite technology, we're able to see the rate and scale of desertification that's happening in these countries. Desertification is the persistent degradation of dryland ecosystems by variations in climate and human activities, affecting the brittle environments of the world. This is where rainfall is seasonal, followed by extended periods of dryness. But desertification is not only an environmental crisis. Affecting already 3.2 billion people around the world, it has social, economic, and political implications too. With our increased use of fossil fuels, industrial-based agriculture, and poor management practices, the rate of desertification has increased dramatically. While climate change, overgrazing, and deforestation get most of the attention, the often overlooked process known as plant oxidation is an essential part of understanding why and how our landscapes are turning into desert. What causes desertification? For centuries, humans have blamed too many animals, livestock overgrazing grasses, as the main problem. This is a deep societal belief based on observation and belief, but not science. Man-made desertification begins when the available rainfall becomes less effective, meaning most of the rain that falls on the land either runs off the soil's surface or is absorbed but then evaporates back out, resulting in both floods and droughts.
Desertification is just a fancy word for land drying up and turning to desert ultimately, and this is a good spot to illustrate it. It happens because of our practices that make the rainfall that we receive less effective. And you see it here where soil is exposed. Any rain soaking into the soil will just evaporate out of it again because this is hot. It's hot even to touch now. And when high rainfall falls, it runs off, and you can actually see the runoff and the layer of litter that has swept off that as water runs. And the saying that people have that droughts cause the bare ground is nonsense. It's the bare ground that causes the droughts. It's the other way around.
Well, what causes rainfall to become less effective? When looking at the vast grasslands of the world, rainfall becoming less effective begins with increased bare ground between grass plants. When an environment is high on the brittleness scale, it is crucial for the ecosystem to have covered soil to retain as much of the rain that falls during the limited rainy period each year. Otherwise, over time, environments begin to become drier and drier, affecting both micro and macro water cycles. Well, what causes grasslands to have large amounts of bare ground between plants? Through over 60 years of boots-on-the-ground research, wildlife ecologist Alan Savory says, "I only found two things that lead millions of hectares of grasslands with a high percentage of bare soil between plants. Too few animals, providing inadequate periodic disturbance while overgrazing plants, and/or fire. Too few large grazing animals, without the herding and bunching behavior, do not provide enough physical disturbance to ensure sufficient biological decay of annually dying perennial grass plants, nor enough trampling to provide soil cover. This means perennial grasslands go under a process known as plant oxidation."
we've just come through 4 months of rain. Now we're going to go into 8 months of no rain, right? So if you watch that piece of land, you see what's happening now. It's all drying. Now all that grass is now dead above ground. So now this mass of vegetation has died. Now it's got to get out of the way by the end of the 8 months, because if it doesn't, it's going to oxidize and it's going to kill the grass. So this is what happens if it doesn't get out of the way. It now turns from biological decay, which is rapid, to chemical breakdown and physical weathering, which is very, very slow.
It is this slow process of plant oxidation that's affecting billions of hectares around the world, increasing bare soil, leading to the cycle of desertification. And it's every year that we need to prevent the buildup of oxidation from occurring in these environments. But when dealing with oxidation and desertification, we humans only have a handful of tools available to us: fire, rest, technology, and living organisms. Fire. For thousands of years, humans have used fire as the main tool to burn all the old oxidizing grass. Fire is rapid oxidation, meaning it can quickly cycle and process lots and lots of built-up vegetation quickly that would otherwise slowly oxidize. According to the Belgian Earth Observatory, it is said that 750 million hectares of vegetation is being burned every year, nearly half occurring in Africa. That is the size of Australia's total landmass being burned every year. And 90% of the fires occur in the dry season, where dead and dormant vegetation, or in other words, oxidizing material that didn't biologically decay, led to the use and increase of fire.
Now, here is a grassland maintained by fire. You see, it does keep the plants alive. Range scientists would classify that as extremely good. Well, is it? That is maintained by fire. So if we look between the plants at the soil, which is what matters, we find the soil is very hard capped, covered with algae, crusted, and from that grassland we're getting these floods. And that is Kruger National Park, being flooded out from grasslands outside the park. And no matter what type of fire you use, early, late, cool, fire exposes soil, pollutes the environment, makes the rainfall less effective. So fire isn't going to do it.
Moving on to one of the most misunderstood tools in the toolbox: rest. Allowing nature to recover and do its own thing, also known as rewilding. We often believe that if we leave nature to recover by itself, we would be able to reverse and deal with the problem of land degradation and desertification. If you watched my video on the brittleness scale, you would remember that ecosystems aren't uniform. And depending where on the brittleness scale you are, that will determine the way an ecosystem responds to rest or rewilding. There are two types of rest: partial rest and total rest. Partial rest occurs when grazing animals are on the land but in low numbers and or scattered most of the time. Total rest means total rest of grazing animals. The effect both partial and total rest has in non-brittle environments is the same: biodiversity and land recovers. But when you move across the scale to the more arid environments of the world, the effect of both partial and total rest is land degradation and desertification. When one has too low animal numbers, one is unable to deal with the buildup of plant oxidation, leading to the cascade effects of that over time. When one has scattered grazing animals in an ecosystem, they begin to overgraze the most palatable plants, and they don't have the herd effect, which again leads to many problems. Hence, it is having grazing animals with the right behavior, bunched and moving, that is the key. What do we know from BBC documentaries that makes animals stick together? Pack hunting predators. Rewilding is a great idea, but it is extremely important to understand the principle of brittle and non-brittle environments, and that unlike non-brittle environments that regenerate with minimal to no disturbance, brittle environments evolutionarily rely on the biological decay from large herds of grazing animals. Alright, technology. Well, we must be able to invent something to deal with plant oxidation and desertification, right? Technological solutions like planting millions of trees, smart irrigation, or even inventing large machines designed to mimic the behavior of animals all attract significant amounts of funding and attention. But they fail to address the root cause of desertification.
What technology can replace biological decay over 2/3 of the world's land every single year? I think we can go into science fiction and you can't even imagine it. Forget it. Technology is not going to do it.
It's very hard to solve a biological problem at such a scale through technology. Even so, technological solutions to certain problems are key and can be highly effective in dealing with environmental problems such as developing efficient renewable energy sources. But certain technologies that try and replicate natural processes are usually very costly, inefficient, and can even be counterproductive as a whole. Living organisms. The missing tool from the toolbox to deal with plant oxidation in the world's grasslands: properly managed livestock. While many blame livestock, especially cows, as being one of the largest contributors to environmental damage and desertification, while true in some respects, it's important to differentiate that it is not livestock or animals that are the problem, rather it's how we manage them. Management puts cows in feedlots, and it's the management that overrests land while overgrazing plants. But little did we know that livestock managed correctly is the missing tool that is so essential in dealing with plant oxidation in the world's grasslands. Fire, rest, and technology have either failed to halt or even accelerated desertification across the world's grasslands. Livestock offer something that no other tool can: the biological breakdown of annually dying perennial grasses. Through trampling and hoof disturbance, they incorporate dead plant matter into the soil, preventing oxidation and promoting nutrient cycling. Their movement also breaks up hard soil surfaces, improving water infiltration and creating conditions ideal for seed germination. When we historically look at the world's grasslands, we often forget the immense numbers of wild grazing animals that once were. Billions and billions of a huge variety of animals connected with their pack-hunting predators provided the animal disturbance necessary to prevent the buildup of plant oxidation. And using livestock as a tool to mimic the historic behavior of these herds is what is needed. It is not to suggest that just by having livestock will solve the problem of land degradation and desertification. Any farmer can tell you the damage livestock can have on the land without the proper management. Livestock can remain one of our greatest challenges, or they can become one of the most powerful solutions for land regeneration. The Savory Institute addresses this problem of managing livestock with a system called holistic planned grazing, demonstrating how livestock can address the persistent degradation of brittle environments. It is a proven planning procedure that mimics the movement and grazing patterns of wild herds of animals. Conclusion: to restore and deal with plant oxidation, land degradation, and desertification, a new agriculture is required. Moving away from the industrial chemical practices to one that relate back to biological landscape functions that are rooted in first principles. Covering bare soil and keeping it covered with living or dead material is the key to restoring soil health and addressing desertification. Our eroded soils need for much more soil organic matter, which allows for much greater water infiltration and retention. The process of plant oxidation and the effect it has on the brittle environments of the world is one of the most urgent problems of our time. We are a tool-using animal, and the need to biologically address plant oxidation is severe. Otherwise, land degradation and desertification, and all that comes with that, will continue. If you want to learn more on holistic plant grazing, I would highly recommend you check out the Savory Institute or this lecture from Alan Savory. Thank you for watching.